Okay, so here is where partial fraction decomposition comes from. Let's say we're trying to solve this problem. We want to decompose this fraction on the left, 8x plus 82 over x plus 5 times x minus 2. We want to decompose that into two different fractions where the numerators are constant values. So a would represent some constant value, b would represent a constant value. And notice that the denominators are just factors of the original denominator. So here's the super long way to do it. Let's work with the right side here. And if we wanted to recombine the right side into a single fraction, well, we would have to find a common denominator, right? So let's cross multiply. I'm going to take the denominator on the right, x minus 2, and I'll multiply that on the top and bottom. And then what was the denominator on the left, the x plus 5, I'll multiply that on the top and the bottom for the right fraction. So then when I do that, I now have a common denominator, which means that I could write the right side as a single fraction. So it'd be a times x minus 2 plus b times x plus 5, and that's over this common denominator of x plus 5 times x minus 2. Well, let's distribute the a and the b. So I would have ax minus 2a plus bx plus 5b. And that's over x minus 2, or x plus 5 times x minus 2. So think about what the left side was. The left side still could be our 8x plus 82 over x plus 5x minus 2. So these are still equivalent. Well, since these are equivalent and the denominators are exactly the same, that means we could just get rid of the denominators and just work on the numerators now. So I have 8x plus 82 is equal to ax, and I'm going to rearrange this so the x's are first. So it's ax plus bx. And then the constant values would be negative 2a plus 5b. Well, if these are going to be equal, look at the terms here. I've got a term with x on the left and have two terms with x on the right. And then on the left, I have a constant term of 82, and on the right, I have these two guys. A and b would be constants, so negative 2a plus 5b should also be a constant. Well, what I could do here is just set the things that have x's equal to each other. So 8x has to be equal to ax plus bx. And then I can set the constants equal to each other. So 82 would have to be equal to negative 2a plus 5b. What we have here is a system of linear equations. So we want to try to solve the system of equations. Well, first thing I see is I've got two equations, but I have three unknowns. I've got an unknown a, an unknown b, and an unknown x. So I need to try to simplify this a little bit. I have to get rid of one of my variables. And I can actually just get rid of the x's. So if I divide everything by x inside that top equation, that would give me 8 is equal to a plus b. And then the bottom, I would have 82 is equal to negative 2a plus 5b. So let's space this out. So there's my b there. So I can solve this system of equations by using elimination. I want to try to eliminate either the a or the b. So let's say I'm going to try to eliminate the a's. So since the bottom equation has a negative 2 in front of the a, if I want to eliminate the a's, I need to have a positive 2 in front of the a up top. Well, I can do that by multiplying the top equation by 2. That means I'll now have 2 times 8, which is 16, is equal to 2a plus 2b. And then in the bottom, I have 82 is equal to negative 2a plus 5b. So now I can solve this by just adding straight down. 16 plus 82 is 98. 2a minus 2a, those eliminate, giving me a 0a. And then 2b plus 5b gives me 7b. And then I'm left with 98 is equal to 7b. So I can solve for b by dividing both sides by 7. And then b is equal to 14. Now that I know what b is as a constant, I can take that and I'm going to plug it into one of the original equations. The top equation would be the easiest here. So 8 would be equal to a plus b, which we know now is 14. And then solve that for a. So a would be equal to negative 6. Okay, so that's the super long way. So you can see how much work that required. So let's see if we can shorten this somehow. Essentially what happened at the end here, once we had our system of equations, we were able to do the elimination method, which essentially eliminated the a's by creating a 0 in front of that a right there. So if we could actually create a 0 for the a in some other method, then that might actually be faster than the method we just did here. And we could also have solved for a by creating a 0 for the b. We could have just as easily eliminated the b's in this step instead of eliminating the a's. So that's going to be our kind of our small goal, is we want to try and eliminate the a and the b by getting those to 0 somehow. Okay, so let's do this another way. So I'm going to rewrite the original problem. 8x plus 82 over x plus 5 times x minus 2. And then we want this to be equal to sum a divided by x plus 5 plus sum b divided by x minus 2. Okay, so let's do this a slightly different way. So remember, the goal is to get a to equal 0 or to get b to equal 0. So I'm gonna work on the a here. So the denominator for a is x plus 5. I'm going to go through and multiply everything times x plus 5. So I'm multiplying the left side times x plus 5. I'm multiplying the a term times x plus 5. And I'm multiplying the b term times x plus 5. Well, when I do that, the x plus 5 is going to reduce with x plus 5 there. And it'll actually cancel with the x plus 5 there. So we're left with 8x plus 82 divided by x minus 2. And then the middle term here, the a, is now just by itself. And then we have plus b times x plus 5 over x minus 2. So remember, and I know I've said this a few times, but remember, our goal is to try to get rid of a or b by making it go to 0. So I could actually use that trick here. I can make this b go to 0. By choosing an x that would make the x plus 5 equal 0. So make b go to 0 by choosing x such that x plus 5 equals 0. So then if I did that, well, x plus 5 equals 0, you could subtract 5 from both sides. That means that x is equal to negative 5. So if I plug in x equals negative 5 into this equation, I now have 8 times negative 5 plus 82 over negative 5 plus 2. That would equal to a. And then plus b times negative 5 plus 5 over negative 5 minus 2. So on the left, we have negative 40 plus 82 over negative, this was supposed to be a minus 2, over negative 7. And then this is equal to a plus b times 0. So we created a 0 there over negative 7. So since we have b times 0, that means that term goes away. And we now have 42 over negative 7 is equal to a. So that would evaluate to negative 6. So we were able to solve for that negative 6, arguably in a faster way than we did it on the left side. And then we could solve for b in a very similar method. You would just have to instead multiply everything by the denominator for the b, which would have been x minus 2, and then you would choose an x that would make the a go to 0. That would have led you to b equals 14. But then there's a faster way. And the faster way here is essentially, it's the way that I showed you in class. So let me do this one more time, but I'll just do it the way that we did it in class. And hopefully this will start to make sense of why we're doing what we're doing. So it's 8x plus 82 over x plus 5, x minus 2. And then that's equal to a over x plus 5 plus b over x minus 2. So notice what happened here is we were choosing a value of x that would make the b go to 0. And the value of x that made b go to 0, the value of x made b go to 0 ended up being the solution to x plus 5 equals 0. And the x plus 5 came from what it was below the a. So if you want to solve for a, we can just set that denominator, the x plus 5, equal to 0. Solve for x. And then our a value would be plugging in that negative 5 into this whole left side, but ignoring the x plus 5, because the x plus 5 canceled out when we did this earlier. So that means that we would have 8 times negative 5 plus 82 over negative 5 minus 2. So negative 40 plus 82 over negative 7. That's going to be 42 over negative 7, which is negative 6. So we were able to get to that negative 6 much, much faster. And then we can find the b value in a similar method. To find the b, we would take the denominator for the b, it is x minus 2. Set that equal to 0, solve for x to get 2. And then we want to go back to, wow, I just crashed. Give me a second. So we would want to go back to this original equation here and instead cross out the x minus 2 and then set x equal to 2 for the rest of the problem. This would give us the b. So b is equal to 8 times 2 plus 82 over 2 plus 5. So 16 plus 82 over 7, which would be 98 over 7, which is 14. So b is equal to 14. So there's 3 different ways that we can solve this through partial fraction decomposition. First method is by far the longest, but just recognize that you're essentially trying to eliminate the a and the b in that final step. So if you can eliminate the a and the b in a different method, that would be a little bit faster. That led us to this second method here on the right. And then the second method on the right, if you recognize what's going on, you can make it a little bit faster using this method here that we learned in class.